Hi, I'm Earl Velasquez, and today we're going to talk about pulse amplitude modulation. This topic will cover its definition, its types, generation, and its demodulation. It will also cover its techniques, advantages, disadvantages, and application. Pulse amplitude modulation is the simplest form of pulse modulation. It is a general signaling technique whereby pulse amplitude is used to convey the message. It is a modulation system in which the signal is sampled at regular intervals and each sample is made proportional to the amplitude of the signal at the instant of sampling. For example, the PAM pulses could be the sampled amplitude values of an analog signal. This technique transmits the data by encoding in the amplitude of a series of signal pulses. So, PAM has two types, single polarity and double polarity. And there are also two sampling techniques, which are flat top PAM and natural PAM. The generation of a PAM signal. So this diagram shows the generation of a PAM signal from the sampler which has two inputs. This can be a modulating signal, or a sampling signal, or a carrier pulse. Thus, the amplitude of the signal is proportional to the modulating signal through which the information is carried. This will result to the generation of a PAM signal. For the PAM demodulation, the PAM signal is fed to the low-pass filter. The low-pass filter eliminates the high-frequency ripples and generates the demodulated signal. This signal is then applied to the inverting amplifier to amplify its signal level to have the demodulated output with almost equal amplitude with the modulating signal. The amplitude then varies depending on the amplitude of the continuous time signal, which produces two techniques of PAM. These are the single polarity and double polarity PAM. A single polarity PAM is a suitable fixed DC bias, which is added to the signal to ensure that all pulses are positive. Thus, the graph produces a positive amplitude that are only present. Double polarity PAM has pulses that are both positive and negative. That is why the graph shows a both positive and negative amplitude presence. Next, for a natural PAM, the starting carrier pulse is equivalent to the instantaneous amplitude of the continuous time signal, and it follows the natural shift of the curve of the continuous time signal for the rest of the half cycle. For the generation of a natural PAM, the continuous time signal x of t is referred as the information or message signal, which is then given to the low-pass filter, which is used to band limit this continuous time signal. It then goes through the multiplier, where another component is present, which is the pulse train generator. These generate train pulses at a constant interval, and its frequency is a sampling frequency Fs, which is always greater than Fm. It then goes back to the multiplier, and the multiplier gives the output, which is nothing but PAM.
Kanino mapupunta ang last vita na to? Sa'yo o sa'kin? Sa'kin. Uulitin ko. Sa'yo o sa'kin?
O, sa akin na.
O...
Akin nga.
Akin
Akin.
na.
In a flat-top PAM, the amplitude of each pulse is directly proportional to the modulating signal amplitude at the time of pulse occurrence. This means that at the starting of the pulse, the value is equivalent to the instantaneous values of the continuous time signal, which remains constant or flat for the rest of the half cycle. This is why it's called a flat-top PAM. The detection of a flat top starts with the application of the PAM signal to the reconstruction filter, or in this case, it is a low-pass filter. It will remove all the high-frequency ripple from the PAM signal. Next, the equalizer will remove the aperture effect, which is present in a flat-top PAM signal. The distortionless signal will then produce a continuous time signal, which is recovered from the PAM signal. So here is an example of a PAM schematic. A PAM is generated from a pure sine wave modulating signal and a square wave generator which produces the carrier pulse and a PAM modulator circuit. A sine wave generator is used, which is based on Wien bridge oscillator circuit. This can produce distortionless sine wave at the output. The circuit is designed such that the amplitude and the frequency of the oscillator can be adjusted using a potentiometer or a channel. The advantages of a PAM is that it is a simple process for both modulation and demodulation. The transmitter and receiver circuits are simple and easy to construct. And the PAM can generate other pulse modulating signals and can carry the message at the same time. PAM also has its disadvantages, like its bandwidth should be larger for transmission of the PAM modulation. The value or the calculation of noise will be great, and the pulse amplitude signal varies, so the power required for the transmission will be more. The applications of a PAM involves it being used in Ethernet communication, used in many microcontrollers for generating the control signals. It is also used in photobiology and is used as an electronic driver for LED lighting.